Hello, this is Azan, and we are from edX by Arbisoft. And I am quite excited to present this topic to our live and online audience, navigating through the code featuring open edX repositories. And I'm quite excited once again to present at the Open edX Conference 2022. All right, so let's talk a bit about agenda that we'll be covering today in the next 30 to 35 minutes. First of all, we'll be giving some introductions about ourselves. Then we'll give a brief talk details how we got to the point on where we are presenting on the topic. And then, since it's featuring open edX repositories, we'll be working down to break code structures that are present in the open edX organization, and then we'll be deconstructing integrations and communications that are happening between each of those services. What are those? Let's find out. And then we'll be giving some tools and some explanation about the tools and how you can use them optimizely for code navigation. It will be followed by a summary, and then on the last we have question and answer, which will take about like 10 to 15 minutes, and we'll open the floor to our live and on-site audience. All right. It says my name, and you can see my picture as well. So I am Azan bin Zaid. I'm a full-time employee at Edley Arbisoft, and I have been working with edX/2U for past 1.5 years. I have worked on a couple of projects in the Open edX and then the edX platform as well, which involves like some of the feature enhancement in microservices. And we have worked on the introducing consumer-driven contract testing. And then we have worked on one of the internal tools. And then you all know that 2U acquired edX. So we are working on the catalog integration as well, followed by some of the XSS fixes that we must do. All right, to our next speaker, Dawood.
Thank you, Azan, for a very energetic introduction. Hello, everyone. I am Syed Muhammad Dawood Shiraz Ali. Like Azan, I'm also very excited to present this talk to all the participants. I've been working with edX2U as part of Arbisoft Adley team for about 3.5 years. I started as a fresh graduate out of university, and my first project was OpenEdX. So these topics resides in home with me. Given the complexity and the very complex nature of the OpenEdX code base, so it is essential to understand how different intricacy and complexities are working in edX code base. Uh, During my tenure at edX2U, I've been fortunate enough to work in many different areas of the code base. And my starting point was with math checks and some accessibility updates. Uh, Followed by that, I have worked with the feature enhancement across various repositories, platform, edXwell, edX proctoring, some Xblocks, uh, the video block transformer that we used within platform. So feature enhancement, and then majorly the development of video encode manager, which was the replacement for our old video pipeline. That was a big project for me. And followed by that, like Azan mentioned, the consumer driven contact testing pilot. It was something that has been discussed within OpenEdX for quite a while, but our team took the initiative and did that pilot. And internal support tools development and sustenance. So these are the tools that are used by our customer and partner support team, and these tools help do their daily operation rather quickly. And lastly, the catalog integration, which is a high value work that our team is doing right now. So my portfolio with OpenIDS interaction is quite vast, so I'm hoping to add some value with this talk today. Now moving back to Azan for the talk details and some examples.
All right. Thank you, Daud, for giving us your brief introduction about your experience with OpenEdX. And it's quite good to know that we work in the same team. And Daud is a very good person to work with. All right. So let's get back to the problem statement that we are focusing today in this conference talk. So our problem is how we are going to navigate into the OpenEdX repositories or while we are developing in the platform. So why it's important? So if you all know that OpenEdX GitHub has 188 open source repositories, and these repositories surrounds with one of the main one is and the oldest one is edX platform. Then we have integrated plugins, and then we have independently deployed applications, IDEs. And with the recent developments in past couple of years, we are now moving towards micro frontends. And so we have those in open source as well. And lastly, we have many utilities, some of which are internationalization. There are others as well. And just alone, edX platform, the repository on GitHub has 175,000 lines of code as of now. That's a huge lines of code to work with. All right. So what we are focusing here today is how there are a number of services and how these services are communicating with each other. All right. So who is the consumer? Who's the provider? How they are communicating? What's the mode of communication? Because for now, we don't have any single window in which we can identify that, okay, which service relies on which. And if I have to follow a certain flow, which path I will take, or the platform is built on which part. So consider an example. I can safely assume that most of us are OpenEdX developers. So when you're developing onto a feature, you have to identify that, okay, this service is communicating with which, and let's say you identify that, okay, this is a dependency graph, and this is how the services are working, but we're still not sure how the code is living into the repositories, which door to knock just to like edit those specific lines of code. So that's our main point, because locating and viewing that endpoint consumed by the consumer is one such task. Just to give some visualization, all right. Oh, let's look at this. This is models relation in one of the services in platform. As you can see, this is how all the models are inherited and related with each other. If you could just see the user one, right into the middle, how many arrows it's coming in, there are arrows going out, and I can just see and look at this graph all day and still try to figure out, okay, what's happening in here, how I can figure it out. Let's make it easy for you, but before that, let's look at one more visualization of the edX platform. The 170 lines of code, you could see this is how it's structured. These are the colonies in which the code is living. You can see the major chunks, LMS and the CMS and the OpenEdX and the core. We'll come to this part a bit later, but let's take a very specific example from Daud that, okay, what we are trying to achieve in here in given scenario. Daud, over to you.
Yeah, thank you, Azan. So starting off with some very basic level examples, but the idea behind telling these examples is that there is a lot of development related complexities involved with these examples. So firstly, the LMS initiated payment flow for learners. So the scenario is that a learner is scrolling the courses on edX.org. They like a course that they want to enroll in. That course is behind a payment track. So they select that course, they enroll in that course, and they are provided with the option to choose their non-audit or verified track. They select the verified track, and that will initiate the payment flow on the basket page. And after the payment, they will be redirected back to LMS. Now, in this 5 simple step example, we have navigated between 3 different systems. The learners started from edX.org, where they were exploring the different type of courses that edX is offering. When they have decided to enroll in a course, they are redirected from edX.org to courses.edX.org, where all the enrollment process is taking place. Uh, Once they have selected the track that they want to enroll, and then they are redirected to our e-commerce system, or the payment system, where they add the payment details, and once their payment is verified, they are redirected back to LMS. So so you can see the complexities that even for this simple flow, there are 3 different systems involved. So for the next example, which is related to the author or the course authoring side, uh, the curation of course on the publisher micro front end. So on the publisher side, course admin can see all the available courses, and if they want to create a new course for a new term, they will create a new course, add the course details, get the course reviewed, and then make it available for the publication. Again, in this simple flow, which is for the admin, the course created by publisher will be first created into discovery service. The discovery service will create an initial entry in Studio, which is in our platform. Once the course information is added, it has been reviewed. The course details will be sent to Studio and e-commerce, which are 2 different services again. E-commerce will process it saves the information, process, and then send the SQO and some more information to LMS. So you can see, even in this simple flow, which is creating a course, we have navigated between 3 to 4 different services, both backend and frontend. So since there are multiple services, that this is something that developer will have to take care of when they're developing and testing this flow out on the local. So this tells you the complexities we'll be expecting with this talk to uncover. So starting off, we'll try to break down the different code pattern and code structures that are offered by different repositories in the upcoming sections. So let's talk about some coding standards and coding patterns that are present in different repositories across OpenEdX. So here we'll break down some code structures, starting with our IDAs, or independently deployed applications. So these applications, they have all their related code, related logic contained within their repositories. You can see the sample of the IDA code format on the cookie cutter applications. Uh, these applications are deployed separately on their own. That's why independently deployed in their name. So they are not reliant on platform or other IDAs for their functioning with respect to deployment. With respect to code practices and the coding structure, they are following the Django's best practices, where each logic is contained in their respective files, such as models, tests, serializers, signals, handlers.py, etc. So each file contains its own logic, and it's not bulky with unnecessary content. With respect to the communication and interaction with other services or IDAs, uh, they use OAuth clients. They can be multiple clients based on the number of communication that each IDA is doing. And some prominent IDAs, license manager, notes API, e-commerce, discovery service, etc. Uh, Now, talking about the general code distribution of IDAs. So, like previously mentioned, that you can see a format on the cookie cutter, but there were some ideas that were curated before the cookie cutter era, so they might not follow the following format 100%, but there will be some consistency with respect to the application structuring. So in the IDA repo, there will be IDA repo name on the top, containing the apps directory, which will contain all the Django application required for the functioning of that IDAs. Uh, for communication point of view, the important one is the API application. It will contain all the exposed RESTful plus non-RESTful endpoints that are utilized by other IDEs or platform. Uh, API directory can contain multiple version of API starting from v0 and it can go to vn. Each version of the API or each version directory will contain at least two files, which are urs.py and views.py. Views.py will contain the views and urs.py will expose those views. Now, in the API directory, there will be a base urs.py, which will expose all the version urs.py. So it will be importing v0, v1, v2, all the URLs and exposing them in API's base urs.py. Uh, Other than API application, there will be a application named core, which will contain the core application logic, and it will contain models, serializers, admin handlers, like following the best Django coding practices. One difference here would be a file called API client.py, or they can be directory called API client, and it will contain various services.py files. These are important files because they will contain the OAuth client that is responsible for communicating with other services. So if there is API client directly and there are multiple uh, resource or services file, that means that IDA is communicating with multiple IDAs or platform. And then there can be non-core helper application depending upon the complexity of IDAs, but that is the general coding pattern of the IDAs. Next up would be some example of the registrar IDA. So on the left, you can see the core application breakdown. You can see the models, permissions, signals, and API client.py. And on the right, you could see the API directory breakdown where we have v1, v2, v3. So it tells that there are multiple type of API endpoints exposed by registrar. Next, we'll talk a little bit about the coding structure of plugins. So these are the simplest bunch among the group. They are the reusable Django packages, and their aim is to enhance the features that are provided by our edX platform. They are mostly installed and exposed via edX platform. Uh, they have their separate code base, their test suites and views are contained in them, but eventually they are installed within edX platform. They can be installed in other IDEs as well, depending upon their utility. So for instance, in the prominent plugins, the edX is something that is installed both in edX platform and some other services because it is our email written engine. But edX proctoring and edX val are something that are installed solely in our platform service. Same goes for the edX when and edX completion. Uh, in terms of the distribution, they will have uh, only a single application or single Django app, and the files are here distributed according to Django coding standard as well, following the IDA pattern. There will be one main app. It will contain the models, views, signals, tasks, etc. The important file or the important module here would be api.py, and it will contain eternal API utility methods that will be used by the platform to utilize plugin. It will sort of provide abstraction of plugin to platform so that platform will not have to worry how the plugin is doing certain things. It will just import the utility API method and call that. Uh, Next, we'll see the edX val screenshot. So as you can see that it is a very simple application. It has an api.py, but it also has models, utility methods, and views.py. The views here are accessed via edX platform because even though the main logic will be contained here, but since these plugins are installed in platform, they will be exposed there. So next, Azan will talk a little bit about the platform coding standards and the MFE standards.
All right. Since Daud mentioned platform a couple of times, let's dig more into what platform is. So platform is the one of the oldest and the first and the foremost repository that we have into the Open edX. So it's actually core logic divided into two things. One is LMS and the second one is CMS. And the CMS is also known as Studio. And these two are the main deriving forces among the Open edX platform. But since they were made, when they were made, they were made with the best practices then. But that turns out to be a little problem for the later. Let's talk about it more. So monolith is it created a monolith that contained everything. So initially that was good, but that leads to some of the problems that we discuss now. So we have a couple of, or maybe more than a couple of dozens of Django applications in the platform. So the number is still increasing, and then the number becomes so huge that it's unable to maintain. And the plugins that I just mentioned, those all plugins are imported into the platform. So when they are imported into the platform, they kind of become part of the platform. And to manage any of these, we'll have to go through, first of all, just go to the platform, find where the plugin is being imported. And then we have to if you have to change something or write a test suite, update a test suite, then we'll have to import the external things. And it becomes a pretty complex process. Same goes with the X block. So X block is again a building block for the platform that works on the same kind of capacity. But all this led to what? The scalability issues. For example, we add some feature and we have to restart the our platform. So our whole services will go down, and then our services will go up again just to test that, okay, whether that small piece of code that we added into a monolith worked or not. Next, we have about the code structure. So that's basically a Django-based Django backend structure that's kept on improving over the time. But we have a lot of unit tests there. That's a good thing. Having a unit test is a good thing, and we appreciate and follow the best testing practices in edX, Open edX platform as well. So every module, every component will have their dedicated test folder. So that's where the things are pretty good. But what happens, as I told earlier, that we have the plugins imported externally, and sometimes the test suite and the starting test condition or the testing server is also imported by external partners, like the external plugins. So that's again becomes an issue, especially while testing and running local dev servers. And then finally, although it's a backend now, but it still had some of the front ends, and that front end is led by Jinja 2 templates and then Mako templates, and then we still have some of the small React applications that we use into the platform, and then there are some static HTML pages, and editing templates is one of the huge pain points for the developers, because finding exact HTML page or the exact static page or the template to edit is one big problem. So all right, so leading on to that, these MFEs that are relatively a newer addition to the platform in the Open edX repositories, but that come with some kind of complexity and some kind of non-complex and a very modest part as well. Let's discuss about them. So the MFEs into the Open edX are mostly React based micro frontends, and they are all bootstrapped with the pre-written front-end platform, which is a common utility, and its API are used by all the platform. As Daud mentioned, in IDS, the OAuth client, but instead in MFEs, we do have our authentication routed via our platform LMS. Okay, so we are in the architecture style of the code. We are the majority of the applications we have are component-based architecture, the CVA, that's common, and the code reside where it's needed. Especially the API calls are stored into the component. The other is like some of the MFEs still use MVC architecture that still supports development. And then like we have common utility with the name front-end platform, we have like common theming library and UI kits, which we named Paragon. And all the UI components, like the button, the nav bar, and everything are all imported by Paragon. And then we customize them. Most important part, how these MFEs interact with the platform or the IDA. That communication is led by REST APIs, and we'll see like how to find those REST APIs and how to communicate, how to work with them. And then since these are MFEs, the very best part is they're all deployed independently without any hassle of infecting our platform. Well, some of the prominent MFEs are front-end app publisher and front-end app learning that are used by thousands of users. This is some general structure that we see into the MFEs. We have the source folder, and then inside components, we have like the specific data part. And in that data directory, our API calls are communicating with the IDA and LMS. And in this part, we'll try to like touch a bit more on it. And then we can have subcomponents. And in the containers, we hold the common UI components like header, navigation, and other stuff. And lastly, if we have the data directory into the source folder, that means we have some kind of local storage or Redux store setup that is required in some of the application. And we are happy to use and leverage that architecture. And now Daud will tell us a bit more about deconstructing the integrations and communication, that how all of things are connected that we have just discussed.
So with the general coding structures standards established, now let's see how we can deconstruct those integration and communication and understand how to locate the related endpoints. So this section will build upon the details that we have discussed in the previous section. And here we will discuss the linkage of IDA with an IDA and or MFE, and secondly, the platform and plugin communication or integration pipeline. So starting off with the IDA or IDA communication linkage, we'll take the perspective of consumer and provider. So one IDA is consumer and other is provider. Consumer IDA is consuming the data through endpoints that are exposed by the provider, and provider is the provider of those data via some exposed endpoints. And an IDA can be both a consumer and a provider. So for instance, in the following two examples, we'll discuss LMS and discovery, where LMS is provider and discovery is consumer. So discovery is using LMS courses API to load course runs information within discovery. And it's also using LMS admin access API to do some API access checks within discoveries. The other example, registrar and discovery, where registrar is consumer and it is fetching some program information from discovery using discovery's program API endpoint. Next, we'll discuss how the consumer side is configured with respect to OAuth. So the Django or the backend IDA will be using OAuth API client from edX REST API client. So this REST API client is a utility plugin that is used by all the IDAs. With respect to common directory pattern, like discussed in the previous section, that in core app, you'll find the remnants of API client.py, API client directory, and it will contain many resource.py file. Resource here is referring to an IDA name. So it can be lms.py, discovery.py, e-commerce.py, etc. Or lastly, resource underscore interface.py. These files will house the OAuth client, the base URL of the resource, and the URLs of the endpoints that IDA source is consuming. And the above pattern is followed religiously after the post cookie cutter era. Some consistency is there, pre-cookie cutter time, and next IDA MFE. Mhm. With respect to coding structure, you'll find a data/api.py file that will contain the API calls, the URLs, base URL of the resource, and the endpoint URLs. So you can see the consistency with respect to IDA. The differences with respect to authentication that we are using an auth client from front-end platform. In the IDAs, the OAuth API client is responsible for handling the authentication. No, this was focused on the consumer perspective where we have the provider base and provider resource URL. Next, we'll see how to identify the endpoints in the provider. So consumer is using a complete URL in the formats of base, provider URL, API, version, and then the resource. Now, in the provider, if we recall the IDA API app structure, that views at the URLs are broken down. So on top level, we'll have IDA followed by apps, API, version, URLs.py. So if we were to search the URL that is used by consumer within the provider repository, we will not find the URL or the view easily because in the IDA app, uh, the structure is broken down. So what we'll do is that we'll search the resource name from the complete URL, and that resource name will map to URLs or view.py respectively. Next, we'll see some linked examples where we have just in the registrar, like we mentioned, there's a program fetch endpoint. So in registrar, the URL is complete discovery API v1 programs, but in discovery, we'll search Flash programs. And you can see in a slide that we mentioned that in course discovery apps API, in v1, there's views and there's programs.py. So you can see the mapping here is that we have mapped the v1 programs UID in registrar to the discoveries API v1 views. Similarly, platform is using Nodes API annotation endpoint, and it's present in v1 URLs. Next, we'll see a brief video uh, that is showing that we've discussed in action with respect to IDA. So here we have a registrar API client where it has discovery base URL, and it's calling program endpoint of the discovery. So you can see the configuration within the API client, and here's the OAuth client that is responsible for the authentication itself. And here we are in discovery code base. You'll see that when searching, I have done slash programs, and then I've added a urls.py file mask. So what it did is that it it's shortlisting all those urls.py where we have the instances of programs. And here we are seeing the program view set, which is a view set being utilized by registrar endpoint. If we click, and you can see the code structure uh, here as well, that it's on apps API v1 programs. So with respect to uh, plugins, it is the simplest integration or communication pathway. So what we have is that platform is importing something from plugin, so it's one-way communication, and the plugins are used in conjunction with the platform flows. So what this does is that it achieves abstraction, and it will contain the plugin logic within the plugin. Next. Here are some examples where we are using edX while API within platform. It's a usage in video module where we're getting some profile information, and in content store where we're creating some video entries. We'll discuss the hands-on experience in the upcoming section, which is our section on using tools to find and navigate the code. Here we'll discuss some of the part of the plugin navigation experience. let's see how we can use some tools for quick navigation, such as PyCharm, VS Code, and GitHub. You might have already seen PyCharm in the action in the previous section when we were searching for programming API in Discovery. But here we go some other features that it provides. Uh, the prominent feature we'll discuss is listing code usage, utilizing interpreter configuration, and search everywhere. So with listing code usage, so say in a code base like edX platform, there is a function that you want to change, but you don't know where it's used or what will be the impact of that change. So with listing code usage or fund usage, you will get all the usage of that function or class in that code base, and it can help identify the risk or severity of the changes, that can do in that module. So that feature is powerful in that regard. Next, the interpreter configuration will configure an appropriate version environment and install repo requirements. And what that will do is that we can jump into the installed packages and plugins with a simple click. So as you can see in the video that we are jumping into edX file API via just one click. The API is being used in platform, but with one click, we are going to its code base. And lastly, the search everywhere feature. Uh, this is one of the powerful features that is up our sleeve, that we can add file mask, include or exclude certain file types, limit search to a certain directory or scope, or even case limit a string that we are searching. On the next slide, we'll see another quick feature in action. So we are back in PyCharm, back in platform. So we are searching V1 courses. We are applying and reapplying URLs by file mask, and you can see that instant change in the results. We can even change the case and see what impact it will provide. So that is the powerful feature on our hands. And over the next slides, Azan will discuss the VS Code and the GitHub search features. Over to you, Azan.
Thank you, Daud. So while we are wrapping up this presentation, so let's discuss on the points. And our tools, VS Code does provide very good code navigation, and it has the listing as was available in the PyCharm. And in addition to that, it has custom key bindings, which can help you fasten up your navigation. Plus point, the edge that VS Code has, it's equally useful in front-end web applications, because it works well with the JavaScript files that are needed for the modern React applications. And it also has some inbuilt features like breadcrumbs. You can navigate in place, and then you have some kind of similar feature with the PyCharm. It's called go to type definitions, implementations, and references. And additionally, it also has a peek. Peek means you can just like click on the function, and it just tells you quickly in the same section that, okay, where it's used anywhere. And we can extend VS Code easily by adding extensions. We can use Git lens. We can use some language specific tools. Last but not the least, GitHub. GitHub is one of the powerful tools in the code, in the source. And then GitHub has introduced search-based navigation, and it has an addition on the cherry on the top is precise code navigation. For now, it's only supported for Python, but it's based on the open source tree sitter and stack graph libraries under the hood. And one of the additional features is we can search across the organization. We know, like, okay, repos are there into the organization. We can just search it anywhere. And we can use one way is some non-conventional way of using a git blame into the PR. And let's see how that works. So the next example that I'm going to show summarizes all of the information that we have gathered in this session. And it starts from finding an API related permissions, and then finally finding what made it add into the code. Okay, let's look at it. If you see, I am searching into the organization, and yeah, So I'm searching course detail into the organization. It gave me a bunch of files. I know from the pattern that my URL would live in, my views would live in views.py. Okay, but I still want to know the URL. I will navigate one step back. I will go to the urls.py. We'll search, okay, what's the path that's being followed? And then I will go to the specific viewpoint, view set, sorry. And then I will go, okay, what permissions are required to view this? And you can see like GitHub is helping us to find the definitions and references of the functions across our repo. And you can see we go to the function that's been used. And here we will see, okay, that's the user-based function that we are looking for. And it's a very smooth process. It helps you diagnose stuff on the go. And just a couple of steps more, and then we will be able to spot the PR that actually added that code. So that is now finding the permissions class who added the permission class. And here we have the permission class. And now we can use the git blame. And we can see the oldest PR that added. And here we go. Now we know, okay, why was this endpoint added, how it's being modified yet, and how are the files that we have used so far. All right, on the next, we have thank you slide for you. And I would like to say a few more words before we move to the Q&A section. Please share your feedback on how was this presentation overall. And this was just a touch base on some part of the tools and the strategies that we have acquired over a couple of years. And we would like to share it with you. You can definitely add more stuff. You can navigate a bit better. And I hope these techniques would provide an efficient optimization to your daily routine working as an OpenEdX developer. Daud, would you like to say a few words before we end?
Yes. Yeah, thank you, Azan. Like Azan said, please provide feedback, or if you have any questions for us, do let us know. This was our first conference level presentation experience for both of us. So if we made any mistakes or we skid off a few places, so apologies in advance. We are looking for your feedback and comments on the overall experience, and we hope that you learned something from this talk, and hopefully there will be more talk coming from us in the upcoming OpenX presentation. And with that, we are open to Q&A. Thank you very much.
Does anyone have any questions? Including the virtual participants? Looks like we may, we have gotten the all good here on the Zoom. Does anyone in the room have any questions? We are good. I think, thank you very much, both of you, for the presentation. And we will rejoin here back in a little under an hour. Do you? You're both on, so if you want to say anything to the room, you're more than welcome to. Oh, we can't hear him. He is talking. Yeah, can you punch him up? Do you mind repeating that? Thank you.
Yeah, I was saying that we're thankful and we excited that we'll be able to present this. We are waiting your feedback and comments, so you can get in touch with us over the email that we have shared at the start of the presentation. Yeah. Azan, do you have anything?
Yeah, just the same thing. Please reach out if you have any more questions related to the subject. Thanks.
Okay, thank you very much. Okay, we will take a break and rejoin here at 3:45. Thank you.